Tesla recently announced plans to achieve a production speed of one vehicle every 14 seconds across its factories by mid-2024. This acceleration is driven by advanced automation, vertically integrated production lines, and robotic systems handling a wide range of tasks. The welding process, for example, is almost fully automated, contributing to a reduction in manufacturing defects from around 5% a few years ago to under 1% today. Quality control processes that once took an entire day now wrap up in just 1 hour per batch, with defects per 10,000 vehicles dropping by 30% since the start of the year. These advancements highlight how Tesla is pushing the boundaries of manufacturing efficiency. The implications of a 14-second production cycle are significant. Take Gigafactory, Texas, which currently produces around 6,000 Model Y vehicles weekly. At a 30-second cycle time, this translates to roughly 120 vehicles per hour, totaling 20,000 units weekly. Reducing the cycle time to 14 seconds would boost hourly output to 257 vehicles, raising weekly production to over 43,000. This represents a 2.14-fold increase, effectively doubling output. When applied across all models, Tesla's total weekly production could surpass 96,000 vehicles, more than doubling its current capacity. Compared to competitors, these numbers are staggering. Volkswagen, Ford, and GM are projected to produce 45,000, 30,000, and 25,000 electric vehicles weekly in 2024, respectively. Tesla's potential 96,000 weekly units would outpace these figures by a wide margin, positioning the company to capture a quarter of the global electric vehicle market, estimated at 375,000 vehicles per week. Dominance at this scale would solidify Tesla's leadership in the industry, though achieving it depends on several critical factors working in harmony. Central to this progress is Tesla's use of artificial intelligence. At Gigafactory, Nevada, over 1,000 AI-driven robots assemble Model 3 vehicles, slashing production times from 30 to 14 hours. Real-time optimization algorithms minimize downtime and maximize efficiency, enabling faster cycles. AI also plays a pivotal role in quality control. Automated inspection systems equipped with advanced cameras and sensors scan for defects, reducing errors by 30% per 10,000 vehicles. Catching issues early prevents bottlenecks, ensuring smooth workflows and maintaining high standards without slowing production. Supply chain management is another area where AI shines. Systems monitor global logistics networks, predict disruptions, and adjust orders automatically. This proactive approach has reduced component shortages by 15%, keeping production lines running smoothly even during external challenges. By integrating AI across manufacturing, quality assurance, and logistics, Tesla creates a cohesive system optimized for speed and reliability. Three-dimensional printing further enhances Tesla's manufacturing agility. The technology accelerates the production of complex components, cutting development time by up to 90%. Custom parts that once took weeks to prototype now materialize in 24 hours, slashing costs by 30% per component. Nearly 10% of Model S parts are now 3D printed, showcasing the technology's growing role. Rapid prototyping and on-demand production allow Tesla to iterate designs quickly and implement changes without halting assembly lines, directly supporting faster cycle times. The Giga Press represents another leap forward. These massive casting machines produce single-piece vehicle underbodies, replacing dozens of individual parts. Traditional methods requiring 30 to 60 minutes per component are reduced to under 2 minutes with the Giga Press, cutting assembly time by 95%. Fewer parts mean fewer potential failure points, simplifying production while enhancing structural integrity. Labor costs drop by up to 40% compared to conventional methods, as automated casting minimizes manual assembly steps. This innovation alone has been instrumental in shrinking production cycles from hours to minutes. Battery manufacturing has also seen dramatic improvements. AI-driven optimizations increase production line efficiency by 25%, trimming 12 seconds from battery pack assembly. Over 90% of battery module tasks are now automated, reducing per-vehicle production time by a quarter. Gigafactories like Nevada and Shanghai produce batteries locally, slashing lead times by up to 30%. With facilities designed for scalability, Tesla can meet surging demand without compromising speed or quality. Strategic factory design plays a crucial role. Facilities like Berlin and Texas employ vertical integration and linear layouts, cutting assembly time by 30%. Automated welding shops operate at 95% efficiency, saving 12% on shipping costs. Each Gigafactory is a hub of continuous innovation, embracing principles like Kaizen to implement thousands of small annual improvements. These incremental gains, from optimized cable routing to reduced machine downtime, compound into significant productivity boosts. Tesla's culture of relentless innovation ensures it stays ahead. By combining AI, cutting-edge manufacturing technologies, and efficient factory designs, the company is poised to revolutionize automotive production. Achieving a 14-second cycle would not only double output but also set new industry benchmarks, pushing competitors to accelerate their own transitions. While challenges remain, Tesla's integrated approach blending automation, real-time data, and agile manufacturing positions it to lead the electric vehicle market for years to come. Tesla's vertical integration extends beyond manufacturing into raw material acquisition. The company has secured lithium mining rights in Nevada and invested in nickel supply chains in Canada, ensuring direct access to critical battery materials. By bypassing intermediaries, Tesla avoids price fluctuations and shortages that plague competitors. For instance, a recent deal with a Quebec-based nickel supplier guarantees 50,000 metric tons annually, enough for 2 million vehicles. This control over the supply chain is vital for maintaining the 14-second cycle, as delays in material sourcing could disrupt tightly synchronized production lines. The Gigafactory's modular design allows rapid expansion. In Texas, Tesla added a new wing dedicated to Cybertruck production in under 6 months, leveraging prefabricated sections and automated construction. Drones survey sites daily, feeding data to AI systems that optimize building layouts for material flow. This agility contrasts with traditional automakers, which often take years to retrofit factories for new models. Tesla's ability to pivot quickly was demonstrated when Gigafactory Shanghai shifted 30% of its Model Y capacity to an updated battery design in just 10 weeks, a process competitors might take a year to execute. Human-robot collaboration is redefining roles on the factory floor. At Fremont, engineers use augmented reality (AR) headsets to overlay digital schematics onto physical machines, guiding repairs in real time. This reduces downtime by 40%, as technicians no longer need to consult manuals or wait for specialists. Collaborative robots, cobots, work alongside humans for tasks requiring precision, like wiring harness installation. These cobots adjust their speed based on human proximity, enhancing safety. In Austin, cobots handle 15% of final assembly, a figure expected to rise to 30% by 2025 as AI improves their adaptability. Tesla's software stack integrates every machine, sensor, and vehicle into a unified network. Machine learning models analyze petabytes of production data to identify inefficiencies. For example, a neural network detected that aligning door panels 0.5 millimeters higher reduced wind noise by 12%, a tweak now standardized across all models. Over-the-air updates extend beyond vehicles to factory robots. A recent patch optimized welding arm trajectories, saving 1.2 seconds per chassis. This closed-loop system where real-world vehicle performance data informs factory adjustments creates a feedback loop that continuously refines both product and process. Sustainability initiatives are now profit centers. Gigafactory Berlin's water recycling system cuts usage by 70%, saving $4 million annually. Scrap aluminum from castings is melted on-site and reused, eliminating waste disposal costs. Tesla's Battery Day roadmap revealed plans for terawatt-scale recycling facilities, aiming to source 50% of battery materials from reused content by 2030. These efforts resonate with regulators. The EU's strict carbon tariffs exempt Tesla vehicles produced in Europe, giving them a €2,000 per car cost advantage over imported rivals. Yet scaling at this pace introduces vulnerabilities. The 14-second cycle leaves minimal buffer for errors. A single malfunctioning robot in Austin once halted the line for 90 minutes, costing 540 vehicles in lost output. Cybersecurity is another concern. A 2023 attempted breach of Texas factory systems highlighted risks. Tesla now employs quantum-resistant encryption and AI-driven threat detection, but the stakes grow as automation deepens. Labor disputes also loom. German unions demand higher wages for technicians overseeing automated lines, arguing their expertise justifies a 20% premium over traditional auto workers. Competitors are adapting. Toyota's smart factories use Tesla-inspired AI for 10-second cycles on hybrid models, while BYD's new Blade battery line rivals Tesla's speed. However, Tesla's first-mover advantage in data accumulation provides an edge. Its AI has processed 100 billion production data points, 10 times more than BYD, enabling more precise optimization. Legacy automakers face cultural hurdles. Ford's CEO admitted retraining engineers schooled in combustion tech to handle AI-driven production has slowed their EV transition. Looking ahead, Tesla's Unboxed Manufacturing strategy aims to deconstruct traditional assembly. Vehicles will be built in large submodules, battery, chassis, interior that snap together like Lego blocks, cutting final assembly time by 80%. Prototypes in Fremont already test this method, targeting an 8-second cycle by 2026. The Cybertruck's exoskeleton, forged in one piece by Giga Presses, previews this future. Success here could render conventional body shops obsolete, much like how digital cameras replaced film. Tesla's vision transcends cars. Its factories are proving grounds for humanoid robots like Optimus, designed to handle tasks too delicate for current machinery. In pilot tests, Optimus bots install seat cushions with millimeter accuracy, a role previously requiring human dexterity. Musk envisions 1,000 Optimus units per factory by 2025, reducing labor costs by another 25%. This shift could redefine global manufacturing, where Tesla's factories become export hubs not just for vehicles, but for AI and robotic systems. The 14-second cycle is more than a metric, it's a manifesto. It declares that speed and sustainability aren't trade-offs but synergies. As Tesla nears this goal, the industry watches, knowing each second shaved off the line echoes beyond assembly plant. It pressures rivals to abandon incrementalism, reshapes supply chains, and accelerates the world's shift to renewables. Whether Tesla maintains this lead depends on balancing innovation with resilience, but one truth is clear. The era of slow, wasteful manufacturing is ending, and the race to redefine it has a clear frontrunner.